Hey everybody, welcome to today's episode of Daily IoT. We are continuing the conversation from yesterday. I was trying to take power from my 24 volt battery on the scooter, wire it into a DC to DC converter, step it down to 5 volts and use that to power my LED strip as well as my particle photon so that I can control the strip. And I had some 24 gauge wire in the scooter that I was going to try and tap off of to get my 24 volts to step down to 5 volts, and I had made the comment, I found online that 24 gauge wire can only handle about 600 milliamps of current, which I'm going to need more than that to power the lights and the photon. And Red Dog, as always, I appreciate you watching, commented on yesterday's video that I should be able to get more out of that. A couple amps, 2-3 amps on a 24 gauge wire. And so, since this is my journey to learn more and to become more of an expert, I thought instead of just going out and buying a thicker wire and calling it a day, I should really look into this and research it more. And so I spent about 3 hours today researching what gauge of wire means and what currents it can carry and ampacity and resistance and voltage drops and all this stuff. And the reason that there's not a really clean answer to how much can a 24, I've got some hookup wire here. This is a 22 gauge hookup wire. How much current can it carry? Well, it's not that simple, but there are lots of tables that will make it that simple. I've got Practical Electronics for Engineers. There's a table in here, page 39, very clearly says that 24 gauge wire can only carry 577 milliamps of current. I found websites that give me different numbers. The Wikipedia entry for AWG, which is how wires are gauged, it's the American wire gauge, says that 24 gauge wire can carry like 3 amps depending on the insulation. And so after all this research, really what I found that this comes down to is heat. With all of this research, I found that wires are going to have a certain insulation rating on them that says at this is my melting point basically as the insulation. If it gets to 105 degrees Celsius, then I'm going to melt. And if you have two wires next to each other, one of them's power and one of them's ground, and it gets too hot and the insulation melts and they touch, now you've got a short circuit and you've got problems. So what I feel like my research today has led me to understand is really this is just about how hot is a wire going to get and is the insulation going to melt. And so the reason it's not a simple answer is because there's properties of how the wire will heat up when certain current passes through it, but then there's laws of thermodynamics that say the ambient air around that wire is going to actively try to cool it once it gets to a temperature above the ambient air and all this other stuff, and it gets really hairy. So most of what you'll find online are rules of thumb, some more specific than others, saying if you have this gauge, solid core versus stranded, and this rated insulation, this is a safe current that you can pass through it. And so what I've come to understand from all of that is that 24 gauge wire with the insulation that I have in the scooter probably is okay up to about 2 amps, but I need more than that. I need about, with all of the LEDs on the strip on at once and the particle photon, and maybe future considerations, like maybe if we want to put some sound on this thing and other things that we might want to run at 5 volts, I could be at 3.5 amps. And so I need something that's going to allow for that and not heat up and melt the insulation on a wire. And so I could go and buy a lower gauge wire, lower gauge being a thicker wire so it can carry higher amounts of current, or I could come up with another solution, which I think is what we're going to try. So Cat6 Ethernet cable. I've got a bunch of this left over from wiring a project in my old house, wiring up my basement, and this is, as listed on the cable here, is 24 gauge wire. 23 gauge wire. And it's got 8 strands of it. Now, the insulation on those little strands is very minimal, so it's not going to have as high an insulation rating as, say, the hookup wire or something more official for running motors and things like that. However, if I can take these and strand them together, so another trick in electronics that I've learned over the years is if you have 2 wires of a lower gauge and you tie them together, the current's going to kind of split evenly across them, and you can get more of pass more current through them safely. And so it's kind of like spreading the work across the wires if you twist them together and run it that way. And so what I have found and a little bit of research says is if I take, with the 8 wires in here, if I use 4 of them for my positive power connection and 4 of them for ground at 23 gauge, the equivalent gauge of wire that I should end up with at that point is around 18 gauge, which, again, according to tables and things like that, I should be able to get like a solid 8 to 10 amps through without it getting too hot. Now, I would not recommend this for one guy on one site that I read was running this through his attic to power screens over Ethernet cable in his house. There's lots of things that could be dangerous there. Please exercise caution and don't do anything stupid to burn your house down. But in the case of the scooter, I'm running a very small distance in open air under the scooter. Worst case scenario, if this stuff starts getting really hot, I can, I'll see that, and there's not really a huge danger. And so I think instead of buying more cable, I'm going to use Ethernet cable to run power to my DC to DC converter straight off the battery. I'm going to create a T junction, a Y cable off of the battery, and I think that's how we're going to get power to our LED strip. That was a lot of words. I hope it made sense. It's kind of a rant. Again, I spent a lot of time on this today trying to figure out what gauge wire to choose for projects, and I feel like I understand it a lot better, but there's still a lot of information to understand. And at the end of the day, I think you really need to understand some hardcore physics and calculus to say with an exact science that this cable will do what you want it to do. And so that's it. That's it for today. I appreciate everybody watching. If anybody knows more about this than I have just said, or if I have said anything wrong or stupid, please let me know down in the comments. I really am trying to understand this better and learn more about it. And so I think we should all learn together, because this is Daily IoT, the show where together we're learning all about the Internet of Things, one day at a time. See you tomorrow.